What if life doesn't need light? What if it doesn't need warmth, trees, oceans, or even air? We often imagine alien life as tentacled creatures on distant planets, basking under strange suns. But what if it's something far quieter, deeper, and hidden? Beneath the frozen soil of Mars, beyond the reach of sunlight, a silent possibility stirs. Scientists now believe that life might not only survive, but thrive, underground, feeding not on light, but on cosmic radiation. On Earth, there are microbes living in the deepest mines, in complete darkness, for thousands of years, drawing energy from radioactive decay. If it can happen here, why not there? And if something is alive under Mars, would it recognize us before we even notice it? The deeper we dig into other worlds, the more we realize. The search for life may not be about looking up into the stars, but looking down into the dark. Mars has always been called a dead planet. No rustling trees, no oceans, no weathered cities lost to time. But modern science is rewriting that silence, starting from beneath the surface. The Martian crust, once thought to be bone-dry and lifeless, is now a frontier of quiet possibility. Satellite readings have revealed patches of subsurface ice only meters below the dusty ground. Even more compelling, in 2020, 2023, and again in 2025, seasonal methane spikes were detected in the atmosphere. On Earth, methane almost always signals life. But how could anything survive on Mars? It turns out, it may not need warmth or light. Cosmic rays, the same high-energy particles we shield ourselves from, can penetrate several meters underground. In the right rock, they trigger radiolysis, a reaction that splits water into hydrogen and oxygen, fuel for microscopic life. On Earth, deep in South African mines, scientists found microbes thriving under identical conditions. No sunlight, only radioactive rock and trace water. These dark biospheres are no longer theoretical, they are real. Mars, it seems, might host a similar underworld, cold, isolated, hidden, and old. If microbial life still clings to the Martian subsurface today, it means one thing. Life isn't rare. It's resilient. It endures. And we may not be alone in the solar system, not because something is watching from the stars, but because something is waiting, just beneath our feet. We often search the stars for alien life, but perhaps we've overlooked the truth hiding on our own world. Deep beneath the Earth's surface, life has proven its resilience in the darkest places imaginable. In the gold mines of South Africa, over 3 kilometers underground, scientists discovered microbes that have lived isolated from the surface for millions of years. No sunlight, no oxygen, only hydrogen and sulfates, generated by the natural radioactivity of surrounding rocks. This isn't science fiction. These creatures are alive, right now. In the ice-bound caves of Antarctica, extremophiles thrive in brine-filled cracks, shielded from solar radiation. In the depths of Lake Vostok, sealed beneath kilometers of ice for 15 million years, bacteria were found, still metabolically active. Even the Atacama Desert, one of the driest places on Earth, hides microbial life clinging to rocks for moisture. What links all of them? Isolation, extremes, survival, and, critically, they mirror the conditions of other worlds. Mars, Europa, Enceladus. These places aren't just speculative science anymore. They now echo environments on Earth we know host life. So if microbes can live in total darkness, deep under ice, or bathed in radiation here, why not there? Maybe we've already met aliens, not from another planet, but born from Earth's own extremes, showing us the kinds of life we should be searching for beyond. In 2029, humanity's hands reached deeper into Mars than ever before. The Rosalind Franklin rover, part of the European Space Agency's long-awaited ExoMars mission, touched down in the desolate expanse of Acidalia Planitia. The choice wasn't random. Years of satellite data showed methane anomalies there, gas that mysteriously appeared and vanished with the Martian seasons. Equipped with a powerful subsurface drill and a suite of spectrometers, Rosalind's mission was simple in purpose but profound in implication. Drill, sample, analyze. 2 meters beneath the surface, the drill encountered a pocket of briny, clay-rich soil. It was exactly what scientists hoped for, a potential microbial haven. The onboard Ma-MIS spectrometer scanned the samples under infrared light, sending data back to Earth. Then came the anomaly. Chemical signatures inconsistent with pure geology, trace organics, a subtle but unmistakable pattern of methanogenesis, a process that, on Earth, only microbes perform. The data wasn't proof, but it was a whisper. NASA and ESA scrambled to confirm. Debate exploded. The media called it the second Viking moment. But deep in the clean rooms of mission control, scientists knew this wasn't a false positive. Something down there was doing something, and it might be alive. Mars, for the first time, wasn't just a target. It was a sight, a mystery with layers waiting to be unpeeled, not just by robots, but maybe soon, by us. At first, it was just noise, strange fluctuations in the sensor data, heat spikes, minor electromagnetic distortions. Engineers assumed it was instrument error until it started responding. Each time the rover adjusted its lights or drill depth, the anomaly changed, like a pattern reacting to a presence. Back on Earth, data analysts ran simulations. The conclusion, the changes weren't random, they were coordinated. That's when the team made a bold move. They sent a deliberate signal, short pulses of light, spaced in prime numbers, the oldest mathematical hello. Seconds later, the soil's chemical composition shifted. Hydrogen levels rose, the methane trace sharpened. A slow pulse of energy, matching the same prime rhythm, echoed back from beneath. It wasn't language, but it was response. No one expected this, not even the optimists. The rover, built only to dig and analyze, wasn't equipped for dialogue. So the scientists waited, sending signals, tweaking outputs, listening, until silence returned. But something had changed. A dormant world had stirred, not with conquest, not with menace, but with awareness. Whatever lived beneath that soil wasn't just surviving, it was watching. Now the question wasn't whether life existed on Mars, it was, have we just introduced ourselves to something ancient and awake? For centuries, we've asked the question, are we alone? But maybe it's time to ask something different. Are we looking in the right direction? We've scanned the stars, mapped galaxies, launched telescopes to the edge of the known universe. And yet, it might be the soil beneath another world, not its sky, that whispers back first. What if life isn't a miracle, but a tendency? Not rare, but patient, hidden, waiting. And what if our greatest mistake isn't that we haven't found it, but that we keep expecting it to look like us? Mars doesn't promise grand civilizations or cosmic empires, but it might hold something more profound, a second Genesis, a living echo in a dead world, proof that life can emerge wherever there is energy, chemistry, and time, even in silence, even underground. And if it happened twice in one solar system, it didn't just happen twice. As we prepare for human footprints on Mars, we must ask, are we explorers or intruders, scientists or disruptors? Because beneath the dust, under miles of rock and ice, something may be listening. Something that never needed sunlight to exist, only darkness and time. So the next time we search the cosmos for companionship, remember, we may not be alone, and we were never above it all.